Okay, today we are going to cover section 8.3, but before we get started, let's talk a little bit about, since we are halfway through the semester, I just entered your midterm grades into the portal grade book. So I don't know how fast it posts to your side of it, but they are entered, so you should be able to see them. Now, if you go in and look at your portal grade book in the portal of your Pulaski Tech website, and see what your midterm grade is. If it is not something that you're expecting, then we need to talk and see what's going on, because I did, before I entered the grades, if you had not completed an assignment, I had to put a 0 in for it, which did drop a couple of people's grades, but you know, that's not the end all be all. Just send me an email and let's see what we can do about that to help you with your grade, okay? Also, 8.3 is the last section of this week, which means on Friday, I will be live Zooming from home instead of on campus, because I'm not going to need the whiteboard or anything, because I'm just going to be asking questions, or anybody can ask me questions that they need to see worked out or something like that. So I will log on Friday on Zoom at 10 o'clock. to see if there's anybody out there that has any kind of questions that you wanted to type in chat or type in privately in chat that you just need to see something worked out or anything like that. So that's what Friday will be. No new material. So the only two videos that you have this week are the 8.2 that I posted yesterday, and then the 8.3 that'll be posted today. Now, 8.3 does get kind of monotonous. It is on what's called synthetic division. And once you get the motion of it and see the steps that you go through, it'll help us down the line in future sections, okay? What synthetic division is it's finding whether or not a number is a zero or a solution of a function, okay? Remember, if it is a zero of a function, it's telling one of the places where that particular function crosses the x-axis, okay? So here are the steps for synthetic division. It'll give you a function like number 1 says f of x equals x cubed minus 14x squared plus 59x minus 70 and then it tells me to find 3 different values. It wants me to find f of 2, f of negative 5, and f of 7. Now so the first thing I have to find is f of 2. So this is another way to do something we've already done before. If I have asked before to find f of 2, that meant to go to this function and everywhere you see, put a 2 in for the x to see what it gives you as the answer, right? So we're going to do this is just going to be a different way to do this. So if I'm finding f of 2 using synthetic division, the first thing I'm going to do is say, whatever this is, and kind of make a little division, long division symbol. This is much easier than long division though. The numbers you're going to put inside your long division symbol are the coefficients of each term. That one's a 1, I just don't see it. This one is negative 14, positive 59, and negative 70. So those are my coefficients. So let's see. I'm going to put the 1, negative 14, positive 59, and negative 70. Here are the steps. First thing you're going to do is drop down whatever the number is there, which is a 1 in this case. Then you're going to start this multiplication process. Whatever is out here, which is 2, multiply it times that 1. Put your answer in the next spot. So 2 times 1 gives me 2. Then I'm going to drop this, add this straight down. Negative 14 and positive 2 gives me negative 12. And then I start the process over again. This 2 times negative 12. Put my answer here. So 2 times negative 12 gives me negative 24. And then add that straight down. 59 and negative 24 is 35. 2 times positive 35 gives me positive 70. Add that straight down. You get a 0. That is your function value. What that's telling you is if that ends up being 0, then 2 is one of the spots on the x-axis that this, if you put it in your y equals and graphed it, it's going to cross it at 2. Okay, and we'll look at that in a minute after we find the other function values to see what they are. Okay, so f of 2 equals 0. Then it wants us to find f of negative 5. Doing the same thing. Oh, I should erase all of it. Need the same coefficients. So 1, negative 14, 59, and negative 70. Do the process. This time I'm just using negative 5 since I'm finding f of negative 5. Drop down the 1. Start your multiplication process. Negative 5 times 1 gives me negative 5. Add it straight down. Negative 14 and negative 5 gives me negative 19. Negative 5 and negative 9 times negative 19. What does that give me? Is 95. If I add that straight down, 154. And all over, negative 5 times 154. Put your answer there. Which gives me negative 770. When you add that straight down, negative 770 and negative 70 gives you negative 840. Which means that is your function value. If you plug in negative 5 into that function, you would get negative 840, which means negative 5 is not a solution or a 0. That means when x is negative 5, what you're coming up with down here is what the y value is. When x is negative 5, the y would be negative 840. So that's why if that ends up being 0, like it did on the first part of the problem, your y would be 0. That's what tells you that it's an x-intercept, right? What makes you an x-intercept is if your y is 0, okay? So f of negative 5 gives me negative 840. And then there's one more on this same problem. The last thing it wants me to find is f of 7. So let's see what the 7 does. Drop down your 1 again. So now you have 7 times 1. Put your answer there. 7 times 1 gives me 7. Add it straight down. Negative 14 and 7 is negative 7. 7 times negative 7 gives me negative 49. Add it straight down. 59 and negative 49 gives me positive 10. 7 times 10 gives me positive 70. And when I add that straight down, I get 0 because negative 70 and positive 70 is 0, which means 7 is a solution or an x-intercept or a 0 of this function. Now, here's the benefit of synthetic division. Instead of just saying, why didn't I just plug that in? Which is essentially what you're doing. The benefit of synthetic division is what you have left over right here. This right here, what is left over is the coefficients of the polynomial that's left after you factor out the 7. So this right here, like if the polynomial, the new polynomial starts off with an x that has one less exponent than this. So this exponent minus 1. So let's see, that would make that x squared, and then go down from there, minus 7x plus 10. That's where you can find the other zeros or the other x-intercepts of this polynomial. Because if you find 1 0 and you're left with an x squared polynomial that you're trying to find the zeros of, what can you do? Since it's x squared, you can go to your quad program, right? That's how you solve x squared. So go to program, down to quad, enter the A, B, and C of what you have left over, which would be 1, negative 7, and 10. So 1, negative 7, and 10 are your A, B, and C. And it finds the other 2 zeros for you, which are 5 and 2. We already knew 2 was, right? So your zeros would be 7, 5, and 2. Okay, this section doesn't require you to find all the zeros. 8.4 will. This synthetic division, if you can get your polynomial, instead of being x cubed or x to the 4th down to an x squared polynomial, you can always find the last 2 zeros by going to your quad. And this is very beneficial because sometimes your zeros are not good whole numbers like this. Okay, what else? How does this all tie together? What does that 7, 5, and 2 mean? Well, let's put this function, I'm going to tie it all together now by putting that function in my y equals x cubed minus 14x squared plus 59x minus 70. What should show when I graph this? It's going to be an x cubed, which means tying this in with the other sections, at most it can have 3 x-intercepts and 2 turning points. What else am I going to know about this function? It's going to cross the x-axis at 7, 5, and 2. It does have 3 x-intercepts. So let's graph this. So here's my function now. It's got 2 turning points. Look where it crosses the x-axis. 2, 5, and 7. So that's what you have found using synthetic division. That's why we had to figure out how to use our quad program earlier. That's why we're using synthetic division now. That's why we need to know what zeros and solutions mean. It all ties together to this graph. Okay, we're not going to do that for every problem. I just wanted to tie it all together so when we do 8.4, you will see the meaning and what's happening. Number 2. There's only 5 of these in this section, and they're all the same type of problem. Number 2 says find f of 3. when f of x equals x to the fourth minus x to the third minus 8x squared plus 42x minus 29. And we're finding f of -3. So -3 is what I'm dividing into this polynomial function to see if it's a 0, to see if I graph this, would it cross the x-axis at -3? So using my coefficients again, I would have a 1 in front of x cubed is -1. In front of x squared is -8. In front of x is 42, and then the constant is -29. So let's see if we use -3 and solve it with synthetic division if it gives me a 0. Drop down your 1 and multiply. -3 times 1, put your answer here. -3 times 1 gives me -3. -1 and -3 gives me -4. -3 times -4 gives me +12. Add straight down. -8 and 12 gives me +4. -3 times 4. Put your answer here. So -3 times 4 gives me -12. Let's see, when I add that straight down, 42 and -12 gives me 30. And then the last one, -3 times 30 gives me -90. When I add that straight down, let's see, what is that, 9? -119, which means this graph would not cross the x-axis at -3. What it would be when the x is -3, the y would be -119. So it doesn't cross it on the x-axis. It goes all the way down to 119 on the y-axis. All right, number 3. Use synthetic division and determine whether the numbers are zeros of the polynomial function. The polynomial function is 2x cubed plus 3x squared minus 14x plus 24. The first thing it wants me to check is f of -4. See if this is a 0. So -4 is what I'm dividing in. Using my coefficients, I'll have 2, 3, -14, and 24. Drop down that 2. -4 times 2. Put your answer there. So -4 times 2 is -8. If I add this straight down, 3 and -8 is -5. -4 times -5 gives me +20. -14 and 20 gives me 6. -4 times +6 is -24, which means the function value is 0. So I know, let's write that over there and remind ourselves, because this one is kind of like you choose A, B, C, or D, and And I need to remember that -4 is a solution because the function value is 0. So f of -4 is 0. Now, essentially, remember, if I started with an x cubed right here, what I'm left with down here is an x squared. Let's see what happens if I put those numbers in my quad, right? Because this essentially, what is left over is 2x squared minus 5x plus 6. Let's put that in our quad to see what happens. Right? Because that should give me, if there are more, that gives me the other solutions. A is 2. B is -5, C is 6. But look what it gives me. 5 plus and minus I, square root of 23 over 4. This comes up with an I as inside my other two solutions. So that's telling me something. My other two solutions to this problem are not real numbers. What would that mean? If I graph this, 2x cubed, 2x to the third power plus 3x squared minus 14x plus 24. Look what it shows. On this graph, I do know that it does cross the x-axis at -4, so there's where it crosses the x-axis at -4. Then it comes way up here. It's doing stuff way up here. Look what it doesn't do. It's not crossing that x-axis again. That's why your answers were I's. That's why they're not numbers on the number line. I's are not on the x-axis. You can't plot a point on an I. It's an imaginary number. Okay, so that's why this is actually the only x-intercept. And remember in 8.1, when we were talking about the maximum number of x-intercepts, and we always said the maximum number is whatever that highest exponent was, that doesn't mean there are 3 x-intercepts. That means at most there are 3 x-intercepts. This one actually only has this one x-intercept. Okay, so I already know on the second part of this problem, when I'm finding f of 3, which is the second part of the problem, my answer is not going to be, it's not going to give me a function value of 0. It's not going to cross it at 3. I would have found that by putting this in the quad. One of my answers would have been 3. Okay, but I do need to find out what it is, because it is going to ask me what the function value of 3 is. So I'm finding f of 3 now. Oh, I did it again. I erased all that. Let's see. 2, 3, -14, and 24. And I'm finding f of 3. I'll drop down my 2 to start. 3 times 2 gives me +6. Add it straight down. 3 and 6 gives me 9. 3 times 9 gives me 27. If I add that straight down, I get -14 and 27 is 13. 3 times 13 is 39. If I add that straight down, I get 63. So f of 3 is 63. That's why 3 was not a solution. So -4 is a solution because f of -4 was 0. 3 is not a solution because f of 3 is 63. All right, number 4. Same thing. H of x this time equals x to the 4th plus 4x cubed plus 2x squared minus 6x minus 1. And I'm finding negative 2 is 0, so I'm finding h of negative 2. I'll do negative 2, use synthetic division. See what I have left. Again, my coefficients in front of x to the 4th is a 1. In front of x cubed is a 4. In front of x squared is a 2. In front of x is negative 6. And then my constant is negative 1. Again, drop it down. Drop down my 1. Negative 2 times 1 gives me negative 2. Add it straight down. 4 negative 2 gives me 2. Multiply here. Negative 2 times positive 2 is negative 4. Add that straight down. 2 and negative 4 is negative 2. So when I multiply here, negative 2 times negative 2 gives me positive 4. Add that straight down. Negative 6 and positive 4 is negative 2 again. So negative 2 times negative 2 is positive 4. And add it straight down. Negative 1 and 4 is 3. So h of negative 2 is 3. So is negative 2 a 0 of this function? No, it is not, because that didn't end up being 0. Now, same problem, it wants to know, is 1 a 0 of this function? So now I'm just finding h of 1. Same problem. Drop down your 1 and start your multiplying. 1 times 1 gives me 1. Add it straight down. 4 and 1 gives me 5. 1 times 5 gives me 5. When I add this straight down, 2 and 5 gives me 7. 1 times 7 gives me 7. Add it straight down. Negative 6 and positive 7 gives you positive 1. And the last one, 1 times 1 is 1. And when I add this down, negative 1 and positive 1 is 0. So yes, 1 is a 0 of this function. If you put that in your y equals and graphed it, one of the places it's going to cross the x-axis is positive 1. Last problem. More synthetic division. This one has some fractions, but it actually ends up not being too bad the way these fractions work out for us. F of x equals x to the 3rd plus 5x squared, not 5, 5 halves x squared plus 13 halves x plus 15 halves. And it wants to know, is negative 3 halves a 0? So negative 3 halves. In other words, does negative 3 halves go into this function evenly and come out with a 0 function value? Let's put in our coefficients. 1, 5 halves, 13 halves, and 15 halves. Drop straight down our 1. And do our multiplication. -3/2 times 1. Put your answer here. Okay, luckily we're starting off with a 1, so it's not too bad that this is a fraction. -3/2 times 1 is -3/2. Another reason these fractions aren't bad is because they have the same denominators. If I have 5 halves minus 3 halves, it leaves me with 2 halves, which is 2 over 2, which is just what? Just 1, isn't it? 5 halves, all you do is the 5 minus the 3, which gives you 2. And since your denominator is a 2, you have 2 over 2, which is just a 1. So luckily, we're just multiplying this -3/2 times 1 again. So let's see, -3/2 times 1 gives me -3/2 again. When I add this straight down, let's see. Again, same denominator, so my denominator is going to be a 2. Let's see what my numerator is going to be. 13 and -3, which gives me 10. Well, what does that mean? What is 10 over 2? It's just 5. So it's still a whole number. Now I need to do -3/2 times 5 and put my answer here. Okay, so let's look at that written out. -3 over 2 times 5. So you can think of it as 5 over 1. Now, the good news about multiplying fractions is you don't have to have common denominator or anything like that, right? You just multiply straight across on top, straight across on bottom. So let's see, what do I get when I multiply the numerators? -3 times 5 gives me -15. Over 2 times 1 is 2. So when I multiply this -3/2 times that +5, it gave me -15 over 2. So what am I getting here? 15 over 2 minus 15 over 2 is nothing. So is -3/2 a 0 of this function? Yes, that is. It means if you graph that, it is going to cross through the x-axis at -3/2 or -1.5. If you wanted to find more x-intercepts, you could put that in your quad. If it came up with i's, that just means it doesn't cross the x-axis anymore. If you do come up with solutions that are not i's, those are your other 2 x-intercepts. Okay, so again, midterm grades are in. If you have any questions on that, let me know. On Friday, I will be Zooming live from home. For anybody that has any questions, shoot me, just come into Zoom on Friday. If not, y'all have a great weekend.